I guess I've already seen this a little bit, but I want to have a chance to talk to you about it, just so you understand a little bit better. There's two kinds of special lines that are not of the form that we're used to. We're used to seeing y equals mx plus b. But when you have a horizontal or vertical line, you're not going to have that form. When you have a horizontal line, as we do here, the blue line, you're going to have y equals c, such as y equals 2. And so what you can see is in this equation, there is absolutely no x value. And so when you're graphing or when you're looking at the equation of this, y is 2 no matter where you are on the line. No matter what x value you pick, so you could have x value of 1, y is 2. You could have the x value of 3, y is 2. You could have the x value of negative 2, y is 2. It doesn't matter where you are, you get this horizontal line, y equals 2. So the idea is, in the equation, x could be anything, but y is always 2 no matter what you pick. Now the other one is the vertical line. So here we have x equals a number, let's say negative 3. And so no matter where you are, you could pick that y equals negative 1, x equals negative 3. You could pick y equals 1, x equals negative 3. Y equals 2, x equals negative 3, and so on. And this will continue all the way through, and you will always get this line y or x equals negative 3. So if we look at some examples here, we're supposed to graph both of these. Y equals 6. So if I'm going to graph that, I'm saying, okay, no matter what x is, x could be anything, x could be 1, y would be 6. X could be 2, y would be 6. X could be 0, y would be 6. X could be negative 1, y would be 6. And so there's our graph, y equals 6. Now for the other one, we have x equals negative 2. So y could be anything. Y could be negative 1, x equals negative 2. Y could be 0, x equals negative 2. Y could be 1, x equals negative 2. And we get the vertical line, x equals negative 2. So let's look at a word problem, I guess. And let's see here. It says students are selling tickets to a school play. The goal is to raise $600. Tickets are $4 for adults and $3 for students. Describe the numbers of adult and student tickets sold that will reach the goal. So I don't know. This doesn't really have too much to do with vertical and horizontal lines. What it does have to do with, though, is writing the equation of a line given this information. We're actually going to end up writing one that is in standard form. If you remember, that means x and y are on the same side, c is on the other, so it's going to look something like this. Okay, so let's just say that x stands for the number of adult tickets, and y stands for the number of student tickets. Okay, so it says it's $4 for adult tickets. So if we take 4 times the number of adult tickets, that should tell us how much we make from the adults. And then if we take 3 times the number of students, that should tell us how much we're going to make off the students. And if we add those together, it'll be how much we make total. Our goal is to raise 600, so that should equal 600. Okay, describe the numbers of adult and student tickets sold that will reach the goal. So I don't know, we could say, well, what if there was absolutely no adult tickets? So 4 times 0 is 0, 3y equals 600, divide by 3, y equals 200. So that would mean if we sold absolutely no adult tickets, we would have to sell 200 student tickets. Now we could go the other way around and we could say, okay, what if, oops, I got rid of that equation, didn't I? What if, what was that, 4x plus 3y equals 600. What if we sold no student tickets and all adult tickets? Well, then we would get 4x equals 600, divide by 4. So then x equals, what do we got, 150. So we'd have to sell 150 adult tickets. So it says describe the number of adult and student tickets sold that will reach the goal. Well, we could do where it's 0 adult and 200 student tickets. Or we could say 150 adult tickets and 0 student tickets. And then we could also try something else. So we could try another version of this. Let's say that we sold, well, I don't know. We just got to try something else. Let's say I sold 20 adult tickets. And then we got to figure out how many student tickets you would have to sell. So 4 times 20 is 80, plus 3y equals 600. Subtract 80. 3y equals 520. Divide by 3. Y equals 170, 173, 170, 174, let's just say, to round up to make sure that you get $600. So we've got 20, comma, 174. All right. And just as a review, now that we've taken some time away, let's look at graphing y equals 1. So I'll make an xy axis. Let me change the color here. Graph y equals 1. So there's 1 on the y-axis. If x was 0, y was 1. If x was 1, y is 1. If x was 2, y is 1. And there's our graph of y equals 1. Now if I want to graph x equals negative 1, I find negative 1 on the x-axis. If y is 0, x is negative 1. If y is negative 1, x is negative 1. If y is 1, x is negative 1. And there is our vertical x equals negative 1. All right, let's go to another word problem here. I know you guys like these. If x represents the number of 4-inch high bricks and y is the number of 6-inch high bricks it takes to reach the top of a 60-inch wall, what are the endpoints of the segment containing the numbers of 4-inch and 6-inch bricks? All right, so let's think of the theme of this problem, okay? The theme of this problem is the length that these bricks cover, okay? It's 4-inch high bricks, 6-inch high bricks. They want a 60-inch wall. So when we're setting this up, our variables are going to be dealing with the length of things. So do we know how many 4-inch bricks we need? We don't. So let's say x is the number of 4-inch bricks. And we don't know how many 6-inch we need, so we'll do y is the number of 6-inch bricks. Okay? So if x is the number of 4-inch bricks, a brick is 4 inches tall, right? And you're going to put brick upon brick upon brick. So if I had 3 bricks, to figure out how tall it is, I would take 3 times the 4 inches that they each are. Well, the 3 is the x value because that's how many 4-inch bricks we have. So I'm going to take 4 times x to tell me how tall are my 4-inch bricks. Then likewise, my 6-inch bricks, I need to take 6 times y, since y is the number of those, to figure out how tall those are. Now we're going to add those together, and that's going to give me a 60-inch wall. Now we have to figure out how many of each brick do you need for that. It talked about the endpoints. The endpoints are going to be on our x and y axes. The reason is, if I were to draw a line here, anything over here means that x is negative, which means we have a negative number of 4-inch bricks. And anything over here means that y is negative, which means we have a negative number of 6-inch bricks, which doesn't make sense physically. So what we're going to do is our graph is going to look something like this, where it starts at the axis and stops at the next axis. So let's figure this out. That means we need to find our x and y intercepts. Remember what's special about a y-intercept. A y-intercept, x equals 0. So I plug in 0 for x. 4 times 0 is 0. We get 6y equals 60. Divide by 6, y equals 10. So my y-intercept is up here at 10. For my x-intercept, remember for the x-intercept, y equals 0. So for my x-intercept, y equals 0. So I plug in 0 for y. 6 times 0 is 0, so I get 4x equals 60. Divide by 4, so then x equals 15. Okay, so that goes off a little bit here. There goes 10, 11, 12, 13, 14, 15. There's my point right there. The graph would look something like this. And answering the question, what are the endpoints of the segment containing the bricks that will reach the top? So my endpoints are, if x is 0, y is 10. And the other one, if x is 15, y is 0. And that would answer that. And then also, if you look at this, anything in between on this line is going to answer that also, which is why a ruler would be really nice so we can see where it crosses the grid. Because any place this crosses the grid, it would also be an answer. So then x would be 6 and y would be 6. So 4-inch bricks and 6-inch bricks would get you all the way top to 60. All right, so we're going to talk about writing equations of lines. This is going to be a little bit in depth here. We'll first start with looking at the equation of a line. Now, if you remember, slope-intercept form is y equals mx plus b. And we find slope by doing the rise over the run, or your y values subtracted over your x values subtracted. What I like to look at, though, is the y loop-d over the x loop-d. Now, if you're looking at a picture like we are below, we're going to be looking at the rise over run. So we're supposed to write the equation of this line. Now, I'm looking for spots, first off, where it crosses, well, one important spot is where it crosses the y-axis. You'll see that's at -3. So b equals -3 in this case. Also, I'm looking for another spot where it crosses the blue grid. And I'm just trying to find a spot where it crosses the blue grid that I can say, all right, let's just pick that spot right there. I can count my slope now. I'm looking at rise over run. So if I follow from this one to this one, I go up 2, and I go over 1, 2, 3, 4, which could be reduced to 1/2, and you should reduce if you can. So the equation for this is y equals 1/2 x minus 3. That is the equation of that line. It's about as easy as I can make it for you. Of course, we're going to have stuff a little bit more difficult than that. For this one, it tells you the slope is -1/2, and it goes through the point 23. When it tells you it's going through this point 23, this is our temporary solution. Now, a temporary solution is going to be very helpful for us. The reason I say it's temporary is because we're not going to keep it all the time. We're just going to use it for a little tiny bit to help us figure stuff out. Now, when you're doing this, y equals mx plus b should be written on your paper. Your job is to replace m with a number and b with a number. That is your job. Now, we already have m because it told us the slope is 1/2, so we're going to plug that in for m. Now, we still have to plug in something for b. Now, in order to do that, you'll notice we have way too many variables. I've got y, I've got x, and I've got b. So we want to solve for b. That means we want b to stay there. So we need to get rid of x and y. We need to replace them with numbers so that the only variable we have is b. That's where our temporary solution comes in. 2 is for the x, 3 is for the y. So I can take 2 and plug it in for x, and 3 and plug it in for y, and find what b is. So 3 equals -1/2 times the x value is 2 plus b. Be careful that you put those in the right spot. The x is 2, the y is 3. Now this one's kind of nice for the math. 1/2 times 2 is 1, but remember I have that negative out in front. So we get 3 equals -1 plus b. Now what's nice about this is we only have one variable. We add 1 to both sides. 4 equals b. So now I know what b is. I'm going to go back to having x and y. So I have y equals negative 1/2 x plus 4. And that'll be my answer. Let's try another one. Alright, write the equation of the line with slope of 2/3 that goes through this temporary solution, negative 3, 4. So once again, I've got y equals mx plus b. I'm going to plug in for my slope since they told me what that is. So we've got 2/3 x plus b. And once again, I've got way too many variables. So I'm going to use my temporary solution. 4 for the y. For the x, I have negative 3 plus b. Since slopes are fractions, you're going to be dealing a lot with fractions, so let's talk about this. To do my math here with the 2/3 and the negative 3, one of the things I'm going to do is I'm going to put this and make this a fraction. That way I can see what's on top and what's on bottom, and I can deal with them appropriately. I have a 3 on bottom and a 3 on top. They cancel each other out. Now notice I replaced them with 1, so that helps with our math. So now I have 4 equals 2 times negative 1 is negative 2 plus b. Add 2 to both sides. 6 equals b. So my equation is y equals, I still have my slope. Notice my x and y are back in the equation. My temporary solution was used to find that b equals 6. And there's my equation. I know this is turning out to be kind of long, but now we have to talk about what happens when you have the words parallel and perpendicular. Remember, we've actually talked about this. Perpendicular slopes, remember you flip it over and change the sign. Parallel, they have the exact same, parallel, they have the exact same slope. So let's look at this problem. It says find the equation line that goes through the point 3, 2. So here's our temporary solution. It is perpendicular to y equals negative 3x plus 2. And then part B says it's parallel to y equals negative 3x plus 2. So we're doing two different problems. Let's start with A, the perpendicular one. So my slope is not negative 3. So when you're doing this, look at this equation as being your parts line. You know when your dad's fixing up a car, or your mom, I guess, if you have that kind of mom. When your dad's fixing up a car, and he has two different cars. He has one that he's fixing up, and the other car he has that's the same make, same model, same year usually, that one's your parts car. Well, this is my parts line. I'm not going to use everything from here. I'm only using parts of it. And the part I really want to use is this negative 3. This 2 right here is not useful. Do not even look at it. Cross it out, scribble it out. You don't like it. Don't use it. Is all you need. The only part you need is that slope. Now in this case, we can't keep the slope exactly as is because it's perpendicular. And so what we need to do, this is negative 3 over 1, I need to flip it over. So I'm going to have 1/3 x plus b. And then, oh, it was negative, so I need my slope to be positive because perpendicular, you flip it over and change the sign. Now we use our temporary solution to figure out what b is. So my temporary solution says that y is 2, x is 3 plus b. 3 over 1, my 3's cancel, so I get 2 equals 1 plus b. Subtract 1 from both sides, 1 equals b. So my equation for A is y equals 1/3 x plus 1. Now for B, this one says parallel. Once again, this is my parts line. I only want one part. I do not care about the y-intercept. Cross it out. We hate it. Don't look at it. What I care about is the slope. Now, since it's parallel to the slope, I'm going to use it exactly as is. It's going to stay negative 3. Now that I have my slope there, I need my temporary solution. It says that y is 2 and x is 3. And then I solve. Negative 3 times 3 is negative 9 plus b. Add 9 to both sides. 11 equals b. So my equation is y equals, what was my slope again? Go back up. It was negative 3x plus 11. So there's my answer to B. All right. I'm going to do this next problem. This might be a good time to hit pause and do the problem yourself so that you can see if you just picked up on it. Remember, perpendicular means flip the slope and change the sign. Parallel means the exact same slope. So for A, y equals, okay, I go to my parts line. I don't look there at all. I just look at my slope. This is 2 over 1. I need to flip it over because I'm doing perpendicular. It was positive. I need to be negative now. X plus B. Now I plug in for x and y. Negative 3 equals negative 1/2 times x is 2 plus b. And write my temporary solution up here. Negative 3 equals, this is 2 over 1, the 2's cancel, negative 1 plus b. Add 1 to both sides, negative 2 equals b. So my equation is y equals, remember my new slope was negative 1/2 x minus 2. For part B, oh, the color's not different enough. Let me pick a different one. For part B, we've got y equals. Now I have to figure out my slope. I'm supposed to be using this for my parts line. I don't care about this. Hate it. Go away. What I do care about is my slope. I want to keep it the same. It's parallel. We keep it the same. So I plug in 2x plus b. Use my temporary solution. Negative 3 equals 2 times 2 plus b. Negative 3 equals 4 plus b. Subtract 4 from both sides. Negative 7 equals b, so y equals, slope again was 2x minus 7. And there's my answer for part B.